We're going to talk about spanning trees and then minimal spanning trees. So here we have a picture of a graph, and we're going to try to turn it into a spanning tree. One of the first things that we need to make sure we understand about spanning trees is the definition of a cycle. A cycle is any path, whether it's large or small, within a graph that begins and ends at the same vertex. Another way of thinking about this is like a loop within the graph. So here, if you take a look at these blue lines, that is a cycle in this graph, and you'll start to notice there are several cycles created in this graph. Here is another type of cycle that you'll see. In this purple or maroon, you'll see a significantly bigger cycle. It has 4 edges, but you'll notice it goes all the way around, and whichever vertex you start on, you can end there as well. Spanning trees are created by eliminating all these cycles. Once we have every cycle removed from this graph, we have what we've created as a spanning tree. Quite simply, all you do is just delete the edges that create a cycle. So once you erase or delete these edges, you want to make sure that each vertex has an edge going to it, at least one, but there are no enclosed loops, closed shapes here. Notice this, there's still one big cycle left in this picture. And we would have one more edge that we would need to remove. There are many different types of spanning trees that can be created from a single graph. You'll notice here's a couple of examples of some spanning trees, all different than how we originally started on that first spanning tree. Here's one more starting back with the original graph. We'll just start eliminating different edges. Notice right there I accidentally deleted one too many edges because there's a vertex without a side, so we gotta undo that and now start eliminating these loops or these cycles. You'll notice the difference between this spanning tree and the others. They are all different, and as long as there are no cycles, you have correctly created a spanning tree. Now I want to talk about minimal spanning trees. Minimal spanning trees are weighted graphs in which a spanning tree is needed. The steps for doing this: first, you want to keep the smallest weight. So identify the smallest weight, keep it, then move on to the next smallest weight. Again, you're going to keep that one as well. Third, keep the next smallest weight unless it creates a cycle. If it creates a cycle, you must remove that edge. And then we need to repeat those steps until all cycles are eliminated. Lastly, we're going to add the weights in order to calculate the solution. So when we first identify the weights, the smallest weight in this picture is 1, so we're going to keep that one. Then we move on to the next smallest weight. Again, it's another weight of 1. We want to keep that, and notice it did not create a cycle. The next smallest is 2. So we're going to keep that because it didn't create any kind of enclosed shape. However, when we look at this weight of 3, we cannot keep that one because it's going to create this cycle here, this little triangular enclosed figure. So we have to remove that edge with the weight of 3. We can move on. There's another edge with a weight of 3. We can keep that one because there was no cycle that was created there. Moving on to the weight of 4. There's 2 of those. We can keep looks like we can only keep 1 of them. We actually cannot keep this weight right there because it will create a loop all the way around. And then we should see here that we cannot keep the weights of 7, 8, 9, 10, and 11. keep going through here. We got to eliminate that cycle with the 8 right there. So when we eliminate that, we have just a couple more cycles to go. And then you'll see here that the solution actually incorporates this 4, but we have to then subtract 4 from that solution in order to properly answer this question. Here we're getting rid of the weights of 10 and 11, and you will see this loop right here that we have to eliminate, and we eliminate that by getting rid of that weight of 4 that we just identified. And whenever you add these up, you actually get a total of 26, but then you got to subtract 4, and the minimum solution is 22. And that is how you do minimal spanning trees.